Good afternoon. It's Miss Hernandez again. Welcome back. Hope you're having a good Friday. Yesterday we started talking about ternary ionic compounds. Today we're going to finish that lecture. Okay. And remember, everything you see here is exactly what's on your packet. We talked about pizzas. We talked about ternary ionic compounds. And one of the first questions that you had in Pear Deck yesterday was identifying ternary ionic compounds. If I give you a list like you see in front of you, which one from these lists, and if you know, we covered this yesterday, which compounds from this list are considered ternary? Yalexia, Mario, Efrain, Hania, Kevin, or Jose. How do I know? Oh, look, Yalexia already gave an answer. The question is, which ones are ternary? Yalexia is already pointing out that letter A is ternary. Okay, so we're going to look at it. Why do you say, Yalexia, that this is ternary? How do I know if I'm working with a ternary compound? Excellent, Mario. Yes, capital letters. But the question is, how do I know that I have binary or ternary? How many capital letters does ternary have versus binary? How it has three or more. Ternaries always have three or more, right? Binaries only have two. So just like Yalexia and Mario are saying in my Google Meet chat, letter A, ternary, letter G, ternary, letter B, ternary, and they're missing one. Which one are you missing, guys? That's ternary. There's one more on this list that's ternary. Which one? F as in Frank. Is that three or more, Alexia? F as in Frank. Do you see three capital letters? Letter E. Very good. All right. Why is letter A? Well, because you got sodium, sulfur, oxygen. That's three elements. B, you got iron, nitrogen, and oxygen. Again, three elements. And then over here towards the bottom, letter E's got nitrogen, hydrogen, phosphorus, and oxygen. That one actually has four. And then the last one that they said was G. We got silver, carbon, hydrogen, oxygen. Again, we're talking about four elements on that compound. All of those are ternary. Letter A, B as in boy, E, and letter G as in girl. The rest are considered binary. They only have two elements. Letter C, two capital letters, two elements. Again, letter D, two elements, lead and iodide. Letter F, magnesium and nitrogen. Those are binary. Everybody else is ternary. Anytime you name ternary ionic compounds, do not change the name of your cation. Do not change the name of your anion. If it's a poly, polys are DNC. Do not change. You do not change the name of polys. The only thing that you're going to change is if you have a negatively charged element as your anion. And what do I mean by that? Well, look at the examples, okay? And I'm just going to talk about it really quick. I'm not going to go into detail because we did discuss this yesterday. And if you need reminders, just go ahead and watch yesterday's video. All right, so if you look at the second example, our polyatomic is your cation. It's the first two elements in this compound. It's known as ammonium, and you can verify that by looking at our valence list. Ammonium, NH4. Okay, so that's what they wrote. The second one, remember, if it's got a positive charge, it's a cation. If it's got a negative charge, it's the anion. And according to binary rules, if you have a negatively charged element as your anion, the ending changes to IDE. So if you look up Cl on our valence list, it's an element. It's a negatively charged element, Cl, with a -1 charge. Anytime you have elements, you drop the ending and you're going to add IDE. And that's how come you see instead of chlorine for the name, it changes to chloride. Everything else stays the same. If you have a poly as your anion, that's the name you see is the name you write. If your anion, your negatively charged anion, is a poly, DNC, DNC, do not change. Write what you see on the list. Okay? We did some practice yesterday. We said that the first one was lithium nitrate. The second one was magnesium hydroxide. The third one, iron 3 sulfate. And then the last one, the fourth one, zinc acetate. All right. This is where we left off. We left off talking about writing formulas for ternary ionic compounds. And according to the reading, if we continue our reading of this section, it says writing a formula for ternary ionic compounds also involve the same steps as for binary. Compounds. And then they break it down to you about the steps. And it says it here, number 1 or bullet point, write the symbol and the charge of the cation, followed by the symbol and the charge of the anion. Use the crisscross method to ensure that the final formula is neutral. Okay, and then they give us an example. Calcium nitrate is composed of a calcium cation and a nitrate anion. All right, so I'm going to be going into Jamboard so that we can address some of these, so that we can go over it in detail, what they mean by that. One second. Just looking at something real quick. Okay. I'll look at it later. It's just, you're suggesting a meeting. Okay. So calcium nitrate, Ca+2, nitrate, NO3 with a -1 charge. So I'm going to go to Jamboard. I'm going to write down what they wrote, what they have. They said Ca+2, nitrate, NO3, -1. So the rules for binary are very simple. Rule number 1, do your charges cancel out? Do they match? Do you have a +2, -2? Do you have a +1, -1? If you have the same number as your charge, they cancel out, right? You just cross them out and you put the letters together. In this case, do our charges cancel out? Does this guy match what you see here? Yes or no in the chat. Alexia, Mario. Yes or no? Are those numbers the same? Definitely not. So what are we going to do? They call it crisscross method. I like to say cross them down. If you cross this guy down and this guy down, your charges, you should end up with calcium with a number 1 at the bottom, no minus, no plus, no minus. Now you got a poly. There is a poly as your anion. You have a number that's crossing down, the number 2. You have to do what we call protect the poly. You must protect it using these guys. What are these guys called? Parentheses, right? And I already drew them on your Jamboard. So the next thing you're going to write is you're going to write NO3 with inside parentheses. And the number that crossed over, which in this case is a 2, right? Not positive 2, just the number 2, that goes on the outside. And we're done. This is what you will do, okay? It takes a little bit more time, but it's not hard. All the information you need is in the valence sheet. All the charges you need, if we look up calcium right here, Ca plus 2, that's what we wrote. What's the name of nitrate? Okay, look up nitrate. NO3 negative 1. Isn't that what we started with? Yeah. Very, very easy. Go to your valence sheet, look them up, write them down, look at the charges. If they are the same number, they go away and you put everything together. If they are not the same, cross down. If there's a poly, protect the poly with parentheses. Okay? The presentation continues talking about the next example. They say is calcium carbonate. Calcium carbonate. Calcium, we already know. They already showed it to us here. Calcium is Ca plus 2. Now, the only thing that we need to look up here is carbonate. CO3 with a negative 2 charge. CO3 with a negative 2 charge. Check if your charges cancel out. Are they the same number? What do you see here, Mario? Do these guys cancel out? Are they the same? Yes or no?
No, one of them is negative.
Okay, but we're not talking negative and positive. The only thing I'm looking at is just the number. Just the numbers right here. Oops. Just the number right here.
They are the same.
They are the same. Anytime they are the same number, and we don't mean plus and minus. We're only looking just at the number. If you see the same number, this guy crosses out, this guy crosses out, and you write what's left over together. Same rules for binary. And we did the same thing when we talked about formula writing for binary. If they are the same number, it doesn't matter if it's a plus and a minus, they cancel out and everything just comes together. Okay? Did I leave my dog outside? I think I left him outside. Oopsie. I'll get her right now after class. Okay. There are some other examples they want us to talk about. They want us to talk about dimercury bonding with chlorine, or chloride is the proper word. Dimercury chloride. Dimercury is a poly. It's not on our valence list. It's not on the valence sheet. It's not here. It should be at the very top because it's a cation. But it is part of the poly list that was given here on Wednesday. And I've already highlighted on the right side, dimercury is Hg with a positive 2 charge. So if we go back to Jamboard and we post it so we can formula write it, well, I'm going to put the dimercury, Hg2 with a positive 2 charge. Now chlorine. Chlorine we had already looked at earlier. Chlorine right here is Cl with a negative 1 charge. Okay, and this doesn't happen often. They just want me to talk about it really quick. They don't cancel out, right? We have to cross them down. And when we cross them down, we end up with this formula. On Tuesday, when we talked about formula writing for binary, we said if you can divide those subscripts by the same number and make them lower, make them smaller, do it. And technically, that rule might apply here. But we don't follow that rule for this. Why? Because this guy is a polyatomic. Those two mercury atoms are bonded. I cannot separate them. And anytime you reduce, you're saying that you're separating them, and that's not possible. So it has to stay as Hg2Cl2 because dimercury is a poly. It doesn't happen often, but I just want to point it out. There's another one that this might happen to. It's called potassium peroxide. Potassium on our valence sheet is a K plus 1. All right, so we're going to write that in. K plus 1. Peroxide is a poly. Towards the bottom of the list, right here. P peroxide is O2 with a negative 2. So I'm going to write that in Jamboard as well. O2 minus 2. If we cross them, right, like we normally do, I should end up with K2O2. And we're done. The only thing is do not reduce because, again, this is a poly. We cannot reduce the formulas for polys. It stays the way you see it. Okay? This doesn't happen a lot, but they talked about it in the presentation. I'm showing it to you because most of you guys are visual learners. You need to see it. Okay? And I read about it yesterday before you left. All right. Now some practice. And we're only going to do the first one and the second one and the last one because the middle one is exactly like the first one. So we're going to do the first and the last one, and then we're going to move on. Okay? Because I want to make sure that we do all the practice problems. Aluminum phosphate and chromium cyanide. All right. Do I have another slide? Yes, I do. All right. And I'm just going to type them in here real quick. What was it? Chromium. It's going to take it off. Aluminum phosphate. Aluminum phosphate. And then there's a second one, chromium 2. Uh-oh. Can you see that? I think I took it out of the box. Okay. Chromium 2 cyanide. Cyanide. Okay. We're only going to do those two for practice. All right. So aluminum, if you look it up on your valence sheet, right here towards the bottom, Al with a +3 charge. So that's what I'm going to write. Al with a +3 charge. Phosphate, if I look it up, over here towards the bottom, PO3 -3. PO3 -3. Isn't it PO4? I think it's PO4. I'll double check it. I put the wrong one. That's why. I put phosphite versus phosphate. Yes, it is PO4. All right. What is our formula? Try it out. This is all I'm going to give you. Type it in the chat, Alexia, if you know the answer. Or if you can at least try it. Mario, type it in the chat. Try it out. What would it be, Alexia? What do I write? Tell me what to write. Come off mute so you can talk to me, girl. ¿Qué pasa aquí? Alexia, are you there? Are you helping out your little brother and sister? Mario, you're next. Help me out. I think Alexia's helping her little brother or little sister. What happens here if you see the same number as your charge? Mario? Yeah, Alexia? Can you guys hear me? Yes, they are the same, right? So what happens? They cancel out, right? And what do I write? What would be my formula? Yeah, Alexia, can you type it in the chat room? All right, if they cancel out, you should end up with AlPO4. Okay? For chromium cyanide, what is the formula for chromium? Here it is, Cr, and it can either be +2, +3, or +6. How do I know which one I'm working with? You're going to look at those Roman numbers, guys. This Roman number tells you what your charge is. So for chromium, it's a +2. For cyanide, well, that's a poly. Cyanide is C as in cat N -1. They don't cancel out this time because they are not the same number. We must use the crisscross method. So we should end up with Cr, protect the poly from the number that's crossing. So put Cn in parentheses, 2. All right. Alrighty, let's see. Pair deck. Let's watch this video and then we'll do our practice. Come on, internet. Oh, there it is.
Ionic compounds with polyatomic ions are called ternary compounds, which means a compound that has 3 different elements. Example, when writing the formula for ternary compounds, you're going to write them just like you would write a binary ionic compound. For example, if you have sodium, which has a +1 charge, and a hydroxide ion, which has a -1 charge, you're going to still crisscross the charges and end up with NaOH. Another example, if you take calcium, which has a +2 charge, and the hydroxide ion with a -1, when you crisscross the charges, you will notice that calcium has 1, but the hydroxide together, there will be 2 of them. When naming these ternary compounds, we had a compound that was NaOH. When naming these, we name the cation as normal, which is sodium. And you just name the polyatomic ion. So it would be sodium hydroxide. Another example, NH4 plus 1 and NO3 with a minus 1. NH4 is the ammonium ion, so it's ammonium. With the nitrate ion, it'd be ammonium nitrate.
All right, so there's your video, guys. I think they could have gotten a better one, but it's okay. Alrighty, so let's summarize today's topic. In summary, ternary compounds are composed of 3 or more elements. Ternary compounds are named by stating the cation first, followed by the anion, and the last point, positive and negative charges must balance out when you are formula writing. Number 1, what is a ternary compound? Number 2, what is the basic rule for naming ternary compounds? And number 3 and number 4 are all about formulas and naming practice.